All right, so let's go through the pre-lab stuff here now. Okay, the problem we're investigating, and remember, you do need to write this in the form of a question in your own words. Okay, what is the relationship between distance and time for an object traveling at a constant speed? Okay, and we went over the types of relationships the other day. We said they were exponential. We said they were linear. Okay, we said they were polynomial. We're not going to work with really anything other than linear. All right. Because yesterday, when we went over what a position versus time graph of an object moving at a constant speed looks like, it was always a straight line because they cover the same distance every second. Everybody follow me there? Okay, so that's what we should be looking at. We should be looking at a linear relationship. You're going to want to work that into your hypothesis. Okay, so for our design, for the variables here, okay, this is going to seem weird, but it's true, so I'm going to give it to you. Okay, our manipulated variable here is time. Okay, we're not actually comparing the carts. We just want to have 5 sets of data to put on a graph. We're not comparing them. Okay, so the fact that the carts are different is not something we're manipulating. Okay, what we are manipulating is time, because the long we kind of determined how long this experiment would run for. Okay, we said 40 seconds and it's over. If we allowed them to travel for 50 seconds, would they have gone further? Okay, or only 30 seconds, they wouldn't have gone as far. Okay, in that way, time affects the rest of the experiment. Okay, so time is the manipulated variable because we've determined how long the experiment will run for. And that affects how far the car can travel. So if time can affect the position of the cart, then position of the cart would be the responding variable. Okay, I know I'm giving you some of these, so you better all get them right. Okay, make sure you got a good explanation as to why. Now, some things that need to be controlled, right? If we're going to get this relationship, the car has to be traveling at a constant speed. If it's constant, then it's also kind of controlled. All right, you got to come up with 2 more. I've given you 3 out of the 5. Okay? You need 2 more controlled variables, things we did the same every time we ran a cart down the hallway. Okay? Okay, for our hypothesis, the if part needs to talk about the relationship between position and time for an object traveling at a constant velocity. Okay, so identify what kind it is. We just talked about that a second ago, so I kind of gave it to you. Okay, the and part describes the experiment. In there, I would mention things like what the timing interval was. Okay, how long was it between each time we put down a marker? 5 seconds. Yeah, every 5 seconds we put down a marker. Okay, so mention that when you're talking about our experimental procedure, right? We ran the carts down the hallway, marking their position every 5 seconds, up to 40 seconds, whatever. Okay, here's the then part. Okay, here what you have to tell me in the then part. Okay, in the then part, how can velocity be determined from the position time graph? Okay, because you are going to be plotting a position versus time graph of this data. And I'm going to tell you one thing right now. You are not just going to use the data from your chart, okay, to do this. Okay? You are not going to do it that way. You are going to use your graph. There's something on the position versus time graph we learned yesterday that can get you velocity. That's the way you have to determine it. Okay? So keep that in mind. We are not doing it this way. Okay? Otherwise, we don't need to build a graph. We could just use the data in the chart. Okay? The point is not to do that. The point is to use the graph. Okay? All right, so for our analysis here, okay, we're going to be building, obviously, a position versus time graph, and I'm going to walk through that with you, okay, of this data, and then we're going to use that graph to get our velocities. Okay, so for question number 1, show how you would calculate the slope of each car's line on the graph. That is, manipulate this equation for slope. Okay, so show me how to manipulate this equation. Not all your answer is going to be is this equation, but manipulated for slope. Okay. Then in number 2, using the equations for each car, calculate how far the car would travel in 150 seconds. Okay, where are you going to get the equations from? From the graph, right? Okay, I showed you yesterday, Google Sheets will spit that out for you. All right, that y equals mx plus b, it'll spit that out for each car. I'll show you that again today, okay, but that's the equation that they're talking about. Use the equation for each car to calculate how far it would go in 150 seconds. And then, in question 3, how long would it take for it to travel 100 meters? Use the equation, solve for that for each car. Okay, show me the math, okay, show all your work in there. That's what I want to see for the analysis. Okay. Then conclusion, same as always, restate your hypothesis and then explain whether it was correct or not, okay, or whether you can accept it or not, okay, could you calculate the velocity using the graph, how did you do it, okay, things like that. And then identify the sources of error in the lab and explain how to improve it. I think if you kind of watched what we did in there, and each time I said, okay, how can we do this one a little bit better? How can we do this one a little bit better? Okay, think about the things that we changed each time. Those would probably be sources of error. Okay, those would be things we'd want to look for. Okay, you don't have to do the class discussion. We'll talk about that when I hand back the labs. Okay, any questions there thus far? All right, what I'm going to need here. Okay, go back to this screen with the graphing lab. Okay, and what we're going to do is we're going to add a file here. Okay, so we're going to go down here to add. Okay, click on the little triangle. Okay. Oh, sorry, create. Sorry, not add. Create a sheet. Okay, we want to create a Google Sheet. When you do it this way, it'll name it the same as the Google Doc that you're working in. Okay, so we'll see that show up here in just a second. Okay, so there it is. Now I've got a Google Sheet that's entitled the same thing, Graphing Lab. All right, I'm going to open that up, and I'm going to start entering my data into the Google Sheet. What's going to go on the x-axis of this graph? Time, yeah. So I want my first column to be the times. So I'm just going to type in here, time in seconds, and okay, I'm going to start at time 0, okay, and then every 5 seconds is what we did. So 5, 10, up to 40 seconds. Okay, and then my next column is going to be the position of cart, and our first cart was cart 12. Right, and that's going to be in meters. I'm just going to widen this column so it all fits. Okay, what was its position at time 0? 0, yeah, we didn't record that, but we know it's the same for every single one of them. So, okay, so they all start at the same spot. Okay, so for cart 12, our numbers are 1.93, okay, and 3.52, 5.16, 6.82, 8.49, and 10.26. Why am I running out here? Did I skip one? Oh, I don't have a 15 in there. That's why my numbers don't work. Sorry, guys, I messed this up. Because apparently I can't count by fives. Okay, so now I've got all my stuff in for cart for the first cart. Okay, I'm going to do the same thing for the next cart. So it'll be position of cart, cart 5. And that's also in meters. Okay, so just keep putting in your data here, guys. Just kind of stay up with me here. Okay, I'll give you guys a minute there to get your data. The first thing we want to do before we even build the graph is we want to copy this data into our lab report. Okay, this is our raw data, and it does need to be in our lab report as our observations. So just click and drag until you've highlighted all of it. Okay, then Control C will copy it and take it to your lab report. All right, so it says here, copy and paste your Google Sheets table and graphs here in procedure. All right, so I'm just gonna put my cursor there, get a blank line, and press Control V. Okay, and I do want to link. That way, if I make any changes, they'll automatically change in my lab report, and I won't have to go looking for them. Okay, so there it is. Okay, it's pasted in there. Looks good. The next thing I'm going to paste in there is my graph, but I don't have that built yet. Okay, so I'm going to go back to my sheets. And now that I have all that highlighted, I'm going to go up to Insert, just like we learned on Monday. Go down to Chart. Click on that. Okay, and then of course it never picks the right kind. Okay, so we're just going to get out of this and we're going to go to the original chart editor, which isn't showing up here. Okay, you know what? We'll do it on this one. We can do it here too. Okay, so we're going to go with data. It says column chart. I don't want a column chart. Click over here on the triangle and scroll down until you get to scatter. Okay, it's right here. So we're going to click scatter. And there we get our line graph with our points anyway. We don't have our lines on there yet. Okay, then I'm going to go to customize right beside data here. Okay, chart style we don't have to do anything with. Axis and titles, we do have to do some stuff with that. So click on the arrow beside chart axis and titles, and we want to put in a more meaningful name than position cart 12, position cart 5. Okay, we're going to call this Graphing Lab. Position versus time. Okay, something like that. That tells us what's on there. Okay, so once we've got that, we can click anywhere and it'll change. Okay, I need to go back up here to where it says chart title. Click on that, and I'm going to change my labels for my two axes. Actually, I don't need to change the horizontal one because I put time in seconds there already. Okay, I just need to put something on the y-axis. So I'm going to click vertical, okay, and put in here that is the position because that's what's on that one. And it's in meters. Okay, so now you can see I've got a label on my y-axis, I've got a label on my x-axis, I've got a good title, okay, I've got all my points on there. All right, so I'm going to collapse that now. I don't need to change anything else about that. And I'm going to go to series, and I'm going to expand that. Okay, so I want to apply one thing to all the series. Right now, a lot of my points are overlapping because my dots are too big. Okay, so I'm going to click on point size, and I'm going to go down to like 2, so they're smaller. Okay, I can see more of the individual dots that way. Okay, and then because they're all different colors, that'll be good enough. Now I'm going to go and put trend lines. Okay, just click on trend line, and it'll do it for all of them. Okay, so we click on trend line, and we get best fit lines for every cart. Okay, they are linear. That's what we want. Okay, and we want to change their labels. Right now it says no label. We want to click on that and use equation. Okay, you're going to watch. If you watch, my legend is going to change quite a bit here in a sec. All right, so now I've got y equals 0.338 times x plus 1.108. Okay, I've got an equation for each cart. Okay. All right, now that I've got that graph, it's pretty much good the way it is. I don't need to change anything now. All right, I'm just going to click out of the chart editor. So click on the X. Okay, there's my chart. And I want to copy that now into my lab report. But here's what I have to do first. My numbers are still highlighted back here. Okay, so I just need to click in an open cell so they're not highlighted anymore. Okay, then click back on the graph so it gets a box around it. Click on the 3 dots, copy the chart, go back to your lab report. My cursor is right here, right below my chart. Okay, and I'm just going to hit Control V. I'm going to keep it linked. Boom. Now my graph is in my lab report. Okay, that is so much faster than having to do this by hand. Okay, so your graph is all built. Now you need to answer the analysis questions using your graph data. Okay, questions there? Do you get behind? Okay, I'll come and help you in a second.